Hello students, in this video I am going to talk to you about the theory behind the degree of unsaturation, or it's also called the index of hydrogen deficiency, and we are going to mathematically derive the formula for this. Okay, so in organic chemistry we use a parameter called degree of unsaturation, du, also known as the index of hydrogen deficiency. Okay, now du indicates the number of unsaturation, double bonds and triple bonds, as well as rings. Okay, rings come in indirect way, but all right. So d of 1 indicates a ring, a single double bond or a ring. A d of 2 indicates two double bonds or two rings, or one double bond plus one ring, or even a single triple bond. Okay, so du is actually the number of moles of hydrogen molecule. Okay, now hydrogen molecule means two hydrogen atoms needed to make the unsaturated cyclic compound into a fully saturated open chain compound. So this is the the definition of du, to visualize it. Okay, so now as an example, ethylene CH2 double bond CH2 requires 1 mole of hydrogen, right, to make it ethane open chain fully saturated. So its du is equal to 1. It's one double bond there. Okay, acetylene got one single triple bond. Okay, CH triple bond CH requires 2 moles of H2 to make it ethane, and therefore what happens, its du is 2, one triple bond. Cyclopropane, now it's got just one ring. It requires 1 mole of H2 to break it up, break the ring, and convert it to open chain saturated propane. So du is equal to 1, one ring. Cyclobutene, now cyclobutene contains a ring and a double bond, right? So it requires 2 moles of H2 to convert it to an open chain saturated butane. So du becomes 2, okay, one ring plus one double bond, as you can see, right? So now let me explain this. Now consider an organic molecule having a total number of n atoms. Okay, so the number of single covalent bonds. Now I am not talking about any double bonds and triple bonds or rings here, just the single bonds alone to connect all the atoms. Okay, without leaving even one out, is equal to n minus 1. See, for example, if you take an ethane, okay, which is a saturated open chain compound, its formula C2H6, it's got a total of 8 atoms, so it has got totally 7 single bonds, right? How is that? 6 CH bonds and 1 CC bond, right? Similarly, ethene, okay, C2H4 has 6 atoms and it's got 5 single bonds. Okay, I'm not counting the 5 bond once again. I'm only counting the two CH bonds on each side of the double bond, as well as the just the single bond of the double bond between C and C. So that total comes to 5. Okay, all right. Similarly, ethyne, I'm not controlling the not counting the triple bonds. It has got 4 atoms and it's got 3 single bonds, right? So now now remember, each single covalent bond is formed by 2 valence electrons of the elements participating to make that bond, right? Okay, so it's a sharing, right, of their valency electrons, right? So as there are a total of n minus 1 single bonds in a molecule, okay, the total number of valency electrons making up this n minus 1 bonds in the molecule is 2 into n minus 1, right? So because each bond is 2 electrons, the valency electrons of each of the participating elements, there are n minus 1 bonds. So the number of electrons in those bonds is twice the number, right? 2 into n minus 1. In a saturated open chain compound where all the bonds are single, okay, this total number of valencies, okay, 2 into n minus 1 will also equal to the sum of the individual valencies of the elements making up that organic molecule, right? So let me mathematically put this to you. Mathematically, this can be expressed as summation of Vi from I is equal to 1 to n is equal to 2 into n minus 1. So an organic molecule containing n atoms, the summation of the valences of each of those elements, okay, is equal to 2 into n minus 1, right? So already, where Vi is the valency of the ith atom in the organic molecule. Okay, so now let us derive this, mathematically derive the the formula for index of hydrogen deficiency, or du. So let us take an organic molecule with the formula CaHbOcNdXe. Now the what is that, the coefficients below, they are the number of atoms of each of those kinds. So there are, as you can see, the molecule has A atoms of C, B atoms of H, C atoms of O, D atoms of N, and E atom of X, right? So the total number of atoms in this molecule will be, which is N, will be equal to A plus B plus C plus D plus E, right? So now the valency of carbon is 4, H is equal to 1, O is equal to 2, N is equal to 3, and X is equal to 1, right? X is halogen, they show valency of 1. So the total available valencies of all these atoms is also 4A plus B plus 2C plus 3D plus E, right? So then from the equation, okay, summation of Vi I is equal to 1 to n, 2 is equal to 2n minus 1, we can see that 4a plus b plus 2c plus 3d plus e equal to 2 into n minus 1, which is a plus b plus c plus d plus e minus 1, right? So for a fully saturated open chain molecule, these sums will be equal. Okay, in other words, all the single bonds must exhaust all the available valencies of the elements in the molecule, right? So that's what it is. Now if the molecule is unsaturated or cyclic, then all the available valencies are not exhausted by the single bonds alone. So that's why they form the rings and the pi bonds and everything, right? So what happens is all the available valencies 4a plus b plus 2c plus 3d plus e, that will be greater than the 2 into n minus 1. So that's what it is. So now this difference is a measure of the du or IHD. Okay, greater is the difference, greater the du or IHD. So that's what it is. So in other words, there's an excess of valency available that goes to make the double bonds rings, and this excess valence is given by the term which is the difference of 4a plus b plus 2c plus 3d minus e minus of the 2 into n minus 1, a plus b plus c plus d plus e minus 1. Okay, so now if you mathematically work on it, you get this excess valency as 2a plus 2 minus b plus d minus e. Now we also know that two valency electrons make a bond, right? So that can add a single H2 molecule. So the actual du or IHD becomes this 2a plus 2 plus b plus d minus e, the whole sum divided by 2, right? So that is the index of hydrogen deficiency or du. So to make the formula more generic, we can say that du or IHD is equal to 2c plus 2 minus h plus n minus x, okay, where c, h, n, x are the number of carbon, hydrogen, nitrogen, halogen atoms present in the molecule. So it's a more generic formula, to make it more easy to remember. So now some interesting observations here. Note that the du is independent of the number of O atoms present. Okay, so it's not involving oxygen atoms at all. So which means oxygen atoms can be added or removed from any organic molecule without affecting its du. So that's what the inference is here. The du strictly depends on the molecular formula alone. It doesn't depend on the structure, which meaning all isomers will show the same du, right? And this concept is not directly related, directly related to saturated cyclic compounds. But the main point here is that this makes sense if the saturated open chain molecule, okay, of that particular compound, the same carbon atoms is taken as a reference point. Okay, all right. Thank you very much and have a nice day. Bye.